Good morning to all. We can start the lesson now. Uh, lastly, you learned about how to calculate that the present value of the various the cash flows, lump sum, annuity, and then the capital recovery, etc. And lastly, you learned about how to prepare a loan amortization schedule. Right. So next concept is called the present value of a perpetuity. Perpetuity. So put the title in exercise book, present value of perpetuity. So the perpetuity is meaning is that it is an annuity that occurs indefinitely. It's a fixed payment. So irredeemable. Preferential dividend is an uh, example for perpetuity. So permanently it will be coming as a dividend, and it can be the payment also, definite payment also. So it is simply given by the present value of a perpetuity is equal to the annuity over I value, annuity over I. So you can take down this example. Suppose an investor, suppose an investor expected the perpetual sum of 500 rupees annually from his investments. So what is the present value of the perpetuity if his interest rate is 10%? So after you have taken down this the example, you can answer it as the 500 is the A value. A value is 500. Uh, I I is 10%. That is the point 1. So you can calculate that the p value is equal to 500 over zero point 0.1. That is 5,000. So a very simple calculation. You can do that for the perpetuity of uh, the indefinite income of payment. So it's a very simple concept. Then you can understand other concept is called the present value of uneven periodic sum. So in your exercise book, take down this title, present value of uneven periodic sum. Then you can write down in the example and do some the work on that. Then you can check your answer. So the present value of each cash flow is to be calculated, and the whole present value are to be aggregated as given by these equations. So this is another problem that in the annuity, it's a equal payment, even payment over the period. But there are some cash flows occurring the different amount in the year. So at the time you can't apply that the concept of present value of annuity or present value of lump sum. So you want to apply this one, uh, a series of the present value of lump sum. So every uh, cash flows, uneven cash flows, is marked as a 1 day, 2 day, 3, something like that. Or cash flow 1, cash flow 2, cash flow 3, something like that. You can add. So the it should be divided by these the present value factors. 1 plus 1 I to the power 1 something like that, it would be going on. Or you can multiply this one with the factors. Already the present value interest factor. So you can understand that with that the illustration here given here 0 to 5 years, 0 to 5 years. So in the first day, at the end of the first year, the 5,000 is coming. Second year, 5,000 is coming. Third year, 6,000 is coming. Then the fourth year, 6,000 is coming. And finally, 1,000 is coming. So individually, you want to convert all these present values. So because the amounts are different. So 5,000 to be discounted. So in this case, the 5% discount rate is assumed. So 4,760, then the 4,535, then the 5,184, then the 4,938, the 6,000. Finally, the 5,000 is coming with a present value of 784. Totally, you can get the series as 20,201. So if you ask any question to calculate that as a series of cash flows, so the total amount would be taken as a correct answer. The total amount is not correct, your answer would not be accepted. So even though you made a mistake on one, then the other are right. Say for an example, out of 5 years, you made a mistake on one, the calculation. The calculation of, but the total also would be wrong. Right, so we don't look at that as the distribution of marks to this the individual calculation. So we provided the whole marks. If it's a 10 marks, the 10 marks would go to that as the total. So everyone, you must recheck your calculation and present your answer. So that's the main problem the students are facing with it kind of problem. So example, you take down this example in your exercise book and work out on that. So consider that an investor has an opportunity of receiving 1,000, 5,000, 1,500, 800 and 1,100 and 400 respectively at the end of the 1 year through 5 years. What is the present value of this stream of annual cash flows if the investor's interest rate is 8%? So I will show you the another method how to do this the calculation easily. That is called the tabulations method rather than applying to the direct formula. So you can take it into the easy method, but only the answer, whatever method, if you are, you can apply whatever style you want, but the answer should be right. So without working, and the answer also cannot be accepted. You must give support the workings, the whatever format. That's why we can't give the marks to this the workings. But you want to add the workings to get the full marks to that the answer, total answer. Sometimes the students make copy from others and put that answer without doing any working. So we assume that if the answer is provided without working, that they should have copied it. Definitely, everyone will have the suspicion about that. So without working, how did they get that answer? So that's the problem. So you take down this example in your exercise book and do the workings. So otherwise you won't learn anything without listening to the lectures on anything passively. You want to work on in your own individual work. So this is up to you. You follow that the course with active participation or the following the instruction given by the lecturer. So we don't have any control over you whether you are not following the course or not working. This is benefiting you only. So it is not benefiting for us. Right. So after you have taken down this exercise, you can provide your answer. So answer is obtained like this 3927.77. That is, you want to use your calculator to get that calculations and adding all these and get the final answer. Uh, so in this junction, I want to give you some other alternatives. So in this example, you can have this uh, year through 5 years. The 5 years cash flow is coming. So what can you do is you want to put in a column the year in order 1, 2, 3, 4, 5 years. The cash flow. Cash flow is given in the question like 1,000, 1,500, 800, 1,100. So you can list out all these. 1,500, what is it? 800, 1,100. Finally, there's a cash flow 400. 400 is okay. Now what can you do is the next column, the third column, you can get that as the present value interest factor. So in this case, 8% you want to find out. So for this, you can use the present value tables that you have downloaded from the website. So you can see that present value table is presented in the table A3. The table A3 you can find that the table values. So you can see that at 8%, and 8% the values are presented here. And 0.9259, 92.9 is there for the first year. Second year, you can see that 8573. Second year 8.73. Third year 7.7938. Then the fourth year factor is there. That is 7350. 7350 is there. Then the fifth year, 6806. So you can obtain these factors from the table. So if you don't have the table with you, that you can use your calculator. You can use your calculator. To get the result. So just you can take the formula 1 over 1 plus I, right? So here you can get that is first value. First value is there. So you can take it as a point 92. 9259. 9259, the 0.9259. It's a factor you want to take from these are the calculator values. If you take a full value, the answer would be wrong. So you want to have the 4 digits value only. For the second, you must have 1.38 squared, and you want to have 1 over it, 0.8573. 0.8573 for the approximation. The third year value would be 7.7938. 7938 is there. Fourth year value, you can take it equal. That is 0.7350. So last year value 5. You can multiply 1, 2, 3, 4, n minus 1. So you can get this got 0.6805, not 6. So there's an approximation. You take 0.6805, that's wrong. So you want to take 0.68 not 6. So the fifth digit should be rounded up to the fourth digit 6 as a 6. So that's why you want to get. Then simply you can multiply all these CF values with that the present value factor. So you can obtain the results. So you can present your results in the in nearest rupee, like this. So this is the result you want to obtain for uh, the multiplication. Then you can get the total. You can get the total, this value, right? So always no need to present it in cents. So you want to put it in the nearest rupee, in the rupee only. So those instruction cannot be given in the question, but you want to follow that as a practice. It's like that. 3,928. So in your answer, so you find this one. So approximation is given 3,928. So this is obtained like this. Yeah. So using this the table value, etc. So in this way you want to answer. If you can do this method also. This method also you can follow. Uh, Using a calculator, you can present the answer in two steps. Two steps. It should be in rupees, huh? So in the answer, always you use the different numbers and everything. Don't forget that you want to present your answer in the relevant units. The denomination should be perfect because we are using the different numbers. So the answer p value should be in the rupees. So example is completed in that way. Then the present value of growing annuity. Put the title present value of a growing annuity. So what do you mean by that? So in the earlier, the previous cases, you learned about annuity. Annuity is the same amount over this period, definite period. But some cash flow annuity would be growing from uh, over the years at a normal rate or constant rate over the normal rate. So it is different from these uneven cash flows. Uneven cash flow is different from the growing annuity. Uh, you can understand that a pattern in the growing annuity. That is the growth rate. Yeah. But in the uneven cash flows, it is not that. The randomly, the number would be different, the amount. So it is calculated using this formula. That is the present value of this the growing annuity would be applied this formula 1 minus as a factor 1 plus g over 1 plus I to the power n over 1 plus the I minus g. So you can take down this formula and the example and find your answer. So you can ask what is g? G is called as the growth rate. I is known that is interest rate. A is annuity. So you want to find out the every year annuity. That is not given. Only the growth rate will be given. Then you want to apply the growth rate in the finding these items. There's no direct readily available factors like the annuity vector for present value vectors, future value vectors are not available for lump sum and the annuity. This is the growing annuity uh, to be calculated by you. So this is a formula that is 1 minus 1 plus g over 1 plus I to the power n over 1 plus I minus g. So you don't worry about the derivation of this the formula. That is not your learning point. So your learning point is only the application. So take down this example also. A dividend stream commencing a 1 year regards at 66 expected to grow at 10% per annum for 15 years and then ceases. The discount rate is 21. What is the present value of the expected series? So you take down this form and the question and work out the answer. Answer is 156.36. So you want to take down this, what is A value? A value is 66. G point 1. G point 1. And 15. I point 21. 21%. So all these variables are known. You can substitute to the formula all this and using a calculator and find that the value. So it is simple that you substitute all these values and using a calculator you check that this amount 456.38 is coming out. This is the value of an annuity due. This is not for you. So it would be taught in advance. Yes, yes. Now you can do some exercises. Calculate that as the present value of 6,000 received at the end of 1 year, 5 year, 15 years, and 20 years, and 50 years, and 100 years. Assume a 5% interest. So calculate the present value of 6,000 received at the end of 1 year, 5 years, 15 years, 20 years, and 50 years, and 100 years. Assume a 5% interest discount rate. Right. So how can you answer this question? So you want to write your answer in the very standard way with the workings and the answer itself. So you want to do the presentation in your answer sheet about your workings. So you can take a calculator and put the answer straight away. Say one example, you could take the point not 5. So reciprocity is that you multiply by 6,000, and the answer is 5,740. Right, for the first question. Then if you can straight away put the answers like that, that cannot be accepted. So you want to do a proper presentation. So this is a way of presenting your answer. So you take the first question. You define the F1, that is the future cash flows coming at the end of 1 year. F1. I is 0.5. N is equal to 1. The P is how much? So you apply that the formula. P is equal to Fn, the present value interest factor, uh, N comma I. So it is better you practice using this method rather than using a calculator, because when you are using a calculator, there is a rounding up problem is coming. So you want to spend time on that also. So better you apply this formula. Uh, Fn, the basic formula, then you substitute there. Fn is F1. Then present value factor you want to identify 1 year to I 5%. If you are confused with what is 1, what is 5, so you can so you can put a percentage, indicate that it is interesting. 5% or 0.05. So you refer the table for these values. So the table value 5% at year 1 is 0.9524. 0.9524. So period 1 is the 5%, 0.924. Then you can substitute these things. This is 6,000. Then you can have this value 6,000 into this one. So 5,714.4. So this is a way of presenting your answer for this kind of question. You can't write that and the final answer to this question. You want to properly present it. What is a one I n and what is the formula that you want to apply? So what is the factor values you obtain from the table, and what is the results finally. All this information should be provided in your answer, full answer, right? For the second question, you attempt that 5 years. The same way, you answer to the second question, B, 5 years. At the end of 5 years, what would be the present value of 6,000? Here, this time you want to define that the F5. If n is 5, then same, n5. So here also you can obtain that the factor value from the table. That is 5 years. 0.835. 0.835 you can obtain. 0.835. So you can confirm these values right or not using your calculator also. But at the junction, no need to confirm. Otherwise, it would be time consuming that if you reconfirm 1.05. 0.7835. Then the result would be 6,000 into this factor 4,701. 4,701 is the third question, 15 years. Third question, 15 years. So you define the F15 and n value 15. Then you can substitute all this value and find that at 15 how much is the 5%. At 15, the table says that it's 0.810. 0.810. So 0.810 is there. You can check with that at the calculator also. If you go to that as a scientific version, scientific calculator, So 1.05 to the power 15. You get this value. So you can get that as the value 1.810. 0.4810. 0.4810 is the value. So you can get the answer 2886. 2886 is the answer. Question number D. Question number D. You can work out 20 years. So you define if 20, 6,000 and then is 20. So you want to calculate the people. So 5% interest. So you can calculate that the 0.3769. So you can check for this the 20 years. Yes, 0.3769 is there. 0.3769 is there. So you can take it 3769. You multiply that 2261.4. So you can check in the calculator also. 0.3769. 0.3769 is there. So it is confirmed that is the correct questions. So you can get the answer 2200 and 2100 61. 200. Two thousand 261. So next question, 50 years. 50 years. So for the answer, 50 years. You want to add this data. Then you can add this the present value interest factor for 50 years. 0.0872. So how can you obtain from the table? So you check for that the values. So it is there. 0.0872. So you can apply it and you can find that value 523.2. You can check these values right or wrong using a calculator also. 1.05 x to the power 50. Then you want to divide it by 1 over 8. So you can check it. It's coming 0.8720. 0.872. So it's the right answer. You can obtain it. Then the next questions. 100 years. So after 100 years, if you receive 6,000, what would be the value today? So you can go by these procedures and find out these are the present value interest factor at 5%. You check for the table, but at the table it is not there. Only 50 years is there in the format, but in other format could be there. So in this case, what can you do? You can apply this on the calculator. So you can take its y x to the power y functions and substitute the 100. You can get these values. And if you divide 1 by these values, so you can obtain these values. That is called 0.0076. 0.0076. So if you make any mistake, your answer would be wrong. You want to recheck that. 0.0076. 4 digits. That's up to, it's okay. Then you can write the answer 45 rupees and 60 cents. So 6,000 rupees received after 100 years would have the value today 45 rupees. So this is a practice we are giving you to the learning about nature of this the present value of lump sum. So you can substitute the same to the future value also. So the future value. Uh, I can give you the practice for you. Then you can have another second question. So the determine the present value of 20,000. Present value of 20,000 each paid at the end of each year of the next 6 years. Assume 9% interest. So this is a case given to you. Present value of 20,000 each paid. So you want to understand what type of cash flow it is. So 25,000 is the annuity, not a lump sum. Each for 5 years, next 6 years, the annuity will be coming. So the discount factor is 9%. So you are required to calculate that as the present value, the annuity. So how can I deal with this question? So you want to collect that the information as given in the first example, and you bring down this formula to apply, then substitute and find the answer. So I present here that the final answer is like that, but you want to do the woodworking on that as I present here. So if 1 to 6, it's called the annuity, 25,000. And I is not 0.9. Then the N is 6. But you want to find out the p value of annuity. So you can recall what is the formula that can use. You would have written down in your exercise book that formula. So you rewrite that formula like this. So always use this kind of the formula, the second versions. That is the annuity is equal to present value interest factor of annuity n comma I. So now you can easily substitute. So at the 6 year 9%. So what is the value? So what can you do that? You can go to your table value annuity. A4 table is there. Annuity. So 9% is your targets. At the year this year, 6th year, 4.4859. 4.4859. This is your target value. So you copy and refer here. 4.48959. So you can use your calculator to calculate this one. It will be diagonal shaping. No need to go for that. You can simply get that value from the table. If you don't have the value in the table only, you can get that as the original formula and substitute and find out this value using calculator. So in this case, you can 20 others, you can substitute 20 others for A and these values and check that 1 lakh and 12,147.58 50 cents. Or you can write this 48. 1 lakh 12,148 is maybe the answer. So I have used this Excel worksheet also to do that, but you can't apply this Excel for your examination and practice purpose. So this is for the confirmation purpose. Easily you can do it. So this is second question. Some may be presented in some this explain the Excel, but you want to follow this method. Present your answer for the examination. Then the next problem you can see. Take down this one. Assume a 11% discount rate. Compute the present value of the series. 10,000, 90,000, 15,000, and 17,500, 22,000 received at the end of 1 year through 5 years. For calculation, use table. Very specifically, it's instructed. So you want to present your answer in some way, standard ways. So you learn it. So the you want to get that answer 59,981.43. Uh, Answer is presented here. Right. So you want to define the individual present and the future values. You can use the CFO. The F is a relevant notation. Indicator that it's coming in future. F1, F2, F3, F4, F5. Then the interest rate discount factor is given the 11% and 1 to 5. You want to find out the total p values. So how can you uh, take that as the formula to be here? Here earlier Earlier you would apply this method series and substitute all the equation like this and present it into steps. Another steps to be included. But here in this case, the our exercise case, you can find an other approach like this. So you want to put here and the F values in the second column and present value at 11% you want to obtain from the table, then multiply each and obtain these results. So in this way you can have this your answer. So it is presented here. So what can you do is that everyone uh, so you first you the first column 1, 2, 3, 4, 5. Then put the FN value for this 10,000, 19,000, 15,000, and 17,500, then 22,000. Then you want to find out this value. That is a major task. So how can you find that the present value interest factor? So from the table, you are advised to use the present table. That is A3. At the percentage 11%. At 11%, you obtain these results. 0.9009. So you can 0.009. You can multiply it by the 10,000. You can get it as 9,009. Second value. Second value is 81 and 16. 8116. So you can take it to the second year. Second year you can have it So you can multiply with 19,000, you can obtain that results. You can check it whether it's correct or not. It's, we use this roundup, it should be 15,420. The next thing, third one, 0.7312. 0.7312, you can write it up as 0.7312. You can check the figures are correct. Don't take that as any other full amount, full figure of these factors. Only the limited factor, limited values you want to take. So 10,968. So okay. Then the fourth factor, that is 0.6587. So you can substitute and 6,587, reject 6,587, 6,587. So you multiply 17,500. 17,500 into 0.6587. So you can take it, that's also wrong, no? 11,527. Been obtained from the So you want to present your answer for each and every calculation at a nearest rupee. Nearest rupee. Then you put the total over. So if you calculate the cents or numbers, then your total answer would be different. So for a fifth year, you want to find out that the factor 0.5935. So you can substitute and uh, get that answer. 13,000 not 56. So now you can get that confirm that all these answers are correct. 9,009 plus 15,420 plus 10,968 plus 7,527 plus 13,087. Yes. The correct answer would be 59,981. According to the procedure, allowed you want to add this one. But if you take long numbers, so that may be the problem for you. So if you use these are the full figures as you obtain from the calculator value, infinity number. So if you multiply these all the cash flows, so you can have this the total value 15,800 0.43. So likely you if you can uh, round up, it's coming like that. But if it is just more than that, point by we would have calculated the different figure. So when you are doing this kind of exercise, you must be careful over these substitutions of values. The rounding up values as given in the workings like this. Then you want to have this another exercise. XYZ bank pays 10% compound interest quarterly. So 10,000 is deposited initially. How much shall it grow at end of 5 years? So this is a multi-period compounding. Anyway, just you can answer it simply. We don't learn it this concept in your syllabus, but you can simply answer it. So answer is 16,386. So how can you obtain this answer? So you want to take the 10,000 as P0 current value. So next you want to do the adjustment with the interest rate. So the 10% to be divided by these quarters value. So there are 4 quarters in a year. So you want to divide the 4 quarters, the interest rate. So for a quarter, the interest rate is coming as a 2.5%. Likewise, the number of compounding, then years also should be multiplied by the quarter. So number of n becomes 20. This adjustment should be done. Then you can apply that this future value interest factor for by factor concept to find out this 20. Fn 20. 4 into 4. So definitely you want to mark all this whether it is done compound. So you want to present your all answers in this way. Then you want to find out this the value for this from the table values. So you can check the table value. Compounding. What is the value? Future value interest factor for 1 to be deposited initially. Now only one deposit has been made. So this is future value interest factor of lump sum. So you want to have the 2.5. But in the table, the PDF format table, the 2.5 is not there. 2 is there and 3 is there. Only the whole number is present. So in this case, what can you do it for it? Sometimes the student may take the two values and divide it by 2. That's wrong approach. So you can't use it. So definitely you want to go for this the calculator for this. For Excel application, you can't use for the examination papers and the practice papers. Don't do that. You can use, you can do the practice using the calculator, non-programmable calculator. So on the Excel also I can find it easily. When I pick a value of this the 28 period at 2.5, 1.6386. So I got to check that it's coming here. So 1.6386 is there. So this is the value I want to have at 2.5%. But don't do the practice in the Excel. You can do the Excel for the confirmation. But you can apply the calculator. So how can you do the calculations? So 1 plus, you can do that the basic formula. 1 plus I to the power n. One plus I to the power n is there, as you have learned earlier in the very first. This is the factor you want to have. One plus I to the power n. So accordingly, applying this one in your calculator, you can find the values. So is that how can you do that? 1 plus here uh, 0.25. 1 plus 0.25. 1 plus 0.2 x to the power 20. So you can obtain the results. But approximation should be done. 1.6386. 6386 is there. So you can get the answer by multiplying 16,386 rupees. So that the compounding done quarterly. So the 10% compound interest rate for 10,000 rupees, giving you the value at the end of the 5 years, which is 16,386. Otherwise, what would be the value for you? 1.1 at the end of 5 years. So you should have the value with this one. So if you multiply this one, only 16,105 rupees would be in your deposits. If it is compounded annually at 10%. But it is compounded quarterly, that is the interest to interest. So your deposits is growing very fast. So it gives more value. 16,386 by quarter. So if it is a monthly, it would be more than that. If it is monthly, it would be more than that. So you can take it with that. If you divide 10% by monthly, so this much of interest rate would be there. So the number of term would be 60. So you should have obtained this value and multiply with 10,000. So your deposit would have grown with 16,453, more than that. So when you are increasing this the compounding, you can get more value. That is a theory. The continuous uh, compounding also is there. Compounding. So that will give you the maximum values. Continuous. So when it is compounded continuously, you can get the more values. Hmm. So the continuous valuations giving the more results. 365 days. Uh, so if it is a continuous daily compounding, so the value of this the 10,000 would be 16,486 rupees. So you can learn that when the compounding is increases, the continuous basis, then that would be the maximum the benefit that the depositor can obtain from the deposit. So in this way, you want to approach this kind of problem when you have this kind of multivariate compounding and you using a calculator, you can have it. Notes is not useful for you. You want to work on directly. Hmm. So no one would be there to help you later, right? So this is a practice you want to do. So next thing, that's all about other problem also would be there. Some procedures to be applied. So all these are the applications of these are the time value concept. So in another 1 hour, you can complete the exercises and later you can do the self exercises by yourself. So you will be trained on the how to do the exercise at this class. Then you can follow that same method later. So it will be continued with the next session and Wednesday. So you can get sleep again.